It's time to start.
So the recording's going, everything's good?
Yeah.
Okay, just making sure you got it.
Yeah, thank you.
Hate to miss that also.
Yeah. Okay, well, what were we doing last night? We were dealing with inequalities. Hopefully some of you enjoyed my junkyard dog story. Are you, Emily? You're what? Yes. Good reason. That's right. Okay, we're going to take a step forward. We've done simple ones right now. Now we're going to do compound ones. Okay, compound ones are a pain, but not horrible. Okay, basically compound ones are telling you two things at the same time, and you've got to draw a conclusion from it. Okay, and it's things like 3 is less than x is less than 5. That would be an example, a very simple example of compounding. Okay, because you're saying two different things. If you say 3 is less than x, you're also saying x is greater than 3, which means an arrow going that way. And then if you say x is less than 5, then that means you've got an arrow going that way, starting at 5. An arrow starting at 5 and an arrow starting at 3. Now, there are two conclusions that can come from that. It can be infinity, everything, but it's not, because I didn't say or equal. Or it could be what we call an inclusion statement. The space from here to here. Just that little piece that is commonly shared. Okay? The first thing we're going to do in terms of dealing with compounding is we're going to discuss the language some more. Because obviously there's some language to begin with, so you know which conclusion to draw. Question?
Oh, me?
Or just propping your elbow?
I'm not just propping my elbow, sorry.
No problem, no issue. Now, where did I get the clicker? There we go. Maze Road, 37th Street. Okay, once again, Maze Road, 37th Street. Two of the terms that we're going to have are union and intersection. When you have a compound statement, it can either be considered a union or it can be considered an intersection. And there are some clues and things we'll get to in a moment to determine which it will be in a given problem. Now, in very loose terms, an intersection means only that part of the road that they share in common. That is the intersection, just like real life. Okay? It's only the parts shared in common. Back to my illustration a moment ago. If I just chose this distance between the two endpoints as the inclusive because they overlap, that would be an intersection. That piece out of the middle. Okay? Union on the other side is anything that's in either one of them. Okay? This one is exclusive, this one is inclusive. This can be anything in either one of them. This one can only be the part they share in common. Okay? I'll just let you read that. We have some symbolism for it. The symbol for intersection is an inverted U. You can't hardly read it up here, but the symbol for a union is a U. Now, U doesn't have the downward leg. It's just a inverted arch themselves. Okay. Questions about this? Okay, now we're going to just do an illustration here. You're given three sets. Set A has these letters in it. Set B has these letters in it. Set C has these letters in it. It asks you to find A union B. What does union mean? Anything contained in either of them. Okay. So we'll look at A and B. They both got A. So A will be a member of this set. They don't both have B. So B will not be a member of this answer. They both do have C. So now we got A and C in our set down here. D is missing from both of them. E is shared in both of them. And some of you are looking puzzled because I'm saying this absolutely backwards. Every one of these is going to be in it. Every one of these, including that one, which is not up here, and that one, which is not up here, and that one, which is not up here, because it's anything that's in either of them. And that's the total set of A union B. Remember, union means anything in either of them. Now, notice we only listed the A once, the C once, the E once, and so on. We only listed once. Now we're going to do an intersection, given these same two. Now we get back to the discussion I had a moment ago initially. You look for only that that's shared in common, the A's, the C's, the E's, and that's it. So that's the intersection of these two. Okay. Now, again, this is the differences in kind of a simple form. Okay, now, what about A intersect C? Only the ones that A and C share in common. You know what? I don't see any shared in common. Do you? So what is the answer? The empty set. A and C. Okay. Well, here's some more. I don't have the answers to those. We're going to skip through those. Okay, here we go. Now they're giving you some information in set notation. Okay, we're stepping our game up a little bit. What does this one mean? This one means, and even though I'm going to graph this, that I know they are too. Here's my number line with my 0, and here's my 0.3. And this is going to say that X is all values smaller and not inclusive of 3. What is that? That's set A. Set B. X is a set of values over here at -2. And it says that X is greater than or equal then anything from -2. This is set B. Set C. X is the set of X values greater than or equal to 5. Well, if here's 3, then there's 5. And it's greater than or equal, my arrow has to go this way. And I've got to have the bracket. This is C. Now that's the graphing of those things. That's what those things mean. What if I had asked you interval notation? -infinity to 3 non-inclusive. -2 inclusive to positive infinity. 5 inclusive to positive infinity. See how easy these graphs make interval notation? This one is -2 to infinity. And this one is 5 to infinity on your interval notations. Now we'll let them show us that. Okay, here's the first one. They graphed it a little prettier than mine again. Okay, now the second one and the third one. Now, what is this? Well, they didn't graph C. They're answering the question, what is the graph of A intersect B? Since in this case, intersect means only the part they share in common, that means we got to whack this off right here. And likewise, this one here. So this piece right here is what we call the intersection, or the shared in common part, or the betweenness. And that's the way I'd like you to think about it, is that is the betweenness. Okay? The answer is everything between here and here. And if you think in that manner, then you'll probably be successful. Okay? And again, I put the interval notations up there. What is the interval notation of the answer to that? Well, -2 inclusive to +3 not inclusive. Okay? Electrified fence, open chain link. Okay, now, let's find the union of A and C. Okay, there's A. There's C. There's a gap, isn't there? There is no possible inclusion. But what did the problem ask us to find? It asked us not for the intersection. If they had asked us for the union, the answer would be the empty set. Okay, because they don't share anything. But since they asked for the union, it's just all of that one and all of this one. But there's a special way we got to write the interval notation for this. Anytime you have a union, there's a chance, a strong chance, that you're going to have a split interval. A piece unioned or added to another piece. So in this case, what we would be talking about is we would be going from negative infinity to, what's that, 3? In non-inclusive union with 5 to positive infinity. So in simple terms, we would have negative infinity to 3, non-inclusive, union with inclusive 5 to infinity. That would be your interval answer for the whole thing. Okay.
So when you have negative infinity is always going to come first.
You always read left to right. I think that's the answer to your question. Okay. Now, what about set notation?
Would it include the empty set?
What?
Would it include the empty set?
No. Set notation would be the set of x values such that x is less than 3 or x is greater than or equal to 5. Basically, you just write these things. Okay. When I say anything in either of them, you think of either or, neither nor. Your English teacher used to tell you that. Or, not and. If I put an and in here, that would be denote an intersection, that it is in this one and it is in that one. Share. Okay, do you see the difference in the language? Okay, you see the word or, you know it's going to be a union. You see the word and, you know that it's going to be an intersection. So that's a couple more
Word problem.
yes, clues. Okay. Probably some of you thought I was kidding when I told you the first night I was going to talk a lot of language. But it's essential if you're going to be successful. Okay, well, you can see their conclusion was the same as mine. Okay, now, find the union or intersection as stated. Well, this. If we read this, we're going backwards now to what we were doing before. Before we were taking a set, graphing it, coming up with the interval notation. Now we're translating interval notation into a graph. We've got a non-inclusive -2, and we go from negative infinity to there. Over here, we've got an inclusive -4 right there. And we've got an unincluded 3. So that right there has endpoints. Okay, that has endpoints. That's not a forever because it doesn't have an infinity there. So we can't use the arrow. Now, the question is, what is the union of these two? Well, it's anything in either of them, right? There is some overlap. It starts with a hard start here. Non-inclusive. And it keeps on going to infinity and beyond. Okay. So that is the solution, and there is the interval notation for the solution. Any question about that one? Okay. Same numbers, same exact numbers as before. Only difference is now they're asking for the intersection, in contrast to the last problem. Well, the first two graphs are still the same. What part do they overlap? They only overlap from this -4 to this -2, non-inclusive. Okay? So here is your solution graphically. And there's the interval of the solution. See if I can keep my glasses from sliding down so bad. It's already getting hot in here, but at least it wasn't as hot as we started last time. Okay, here we go, solving them now. All we've been doing up here is kind of getting an orientation into what they are. So we'll solve them. Solve and graph each inequality separately. Haven't we been doing that? We've made one graph for the first one graph for the second set, and then we've been figuring it out. Okay, well now, if they're joined with the word and, we're going to find the intersection. I told you that already. If they have the word or, then they're going to be unions. And you give your final answer either in interval notation or set builder. And for right now, I'm probably going to be doing both. The default is interval. Okay, the desired solution default, unless it says set, I'm expecting interval. Okay, besides it's easier. Okay, say again. I don't know that you really need to write that down if you want to, okay. Okay, so here I have two statements. And what kind are these? They are an intersection. Now, I want you to use this procedure that I'm about to tell you, whether it's an intersection or whether it's a union. I realize that some of your school teachers may have allowed you to work both ends against the middle of an equation. If you had something like this. You had something like 3 is less than x plus 2 is less than 7. I realize some of your teachers might have let you work both sides against the middle to bring your steps in. Don't. It will increase your possibility of errors. Okay? If you do it the way I'm going to show you to do it, you're not going to have issues. Okay, so let's go back to this. Remember what basically we're going to divide this in half here. We're going to work this problem and we're going to work this problem. Okay? So I guess I'll just click through this. In this case, I'm going to divide both sides by -2. But when I do, I have to flip symbol. Remember that from last night? And I carry it on down. So I've got x is greater than -3. Over here, I've got this add-on 5. So I got to move it over there as the first step. So I do that, and I get x less than or equal to 2. So there's my second answer. Now, here's those two answers. There's the graph of the first one. And you wouldn't necessarily have to write that down. There's the graph of the second one. Because this says that that is an inclusion, anything in either, shared in common, right? It's got to be in this one and it's got to be in that one. Then that means we're only going to have this region from here to there as our answer. Because this will create endpoints of the shared domain. So there's your shared graph. Now, interval notation answer. -3 non-inclusive, comma, 2 inclusive, done. Look at this. Look at this. How in the world did they get that business out of these? Well, you got the x here, so they put it in the middle. They're going to put this one like this, but this one we've got to flip to make it fit that model. So if we flip this, then we're going to have -3 is less than x, because remember when you use the reflexive property, you also have to flip symbol. So now here is the same x, here is this symbol, and here is the -3. That's how they got this thing. So I did some the or equal in there. Okay, that's how they got that set notation. This is typically what an inclusion or an intersection will look like. Almost always. Okay. I have to remember I need to stand more on this side instead of that side for the sake of the video. Okay, solve this compound inequality. We got this business is less than that. We got this business is less than that. Oh, by the way, let me back up. Notice in this, both symbols are facing the same direction. That is an absolute requirement. Both either have to go this way or they both have to go the other way. Okay. Now back to this problem. The only thing that makes this one hard is the decimals. Okay. And it's going to make our graphing a little bit silly. Okay. For example, if we had 12.3, we're going to draw the graph, put a 12, and it's going to be just a little to the side. Well, let's go on. We're going to solve this one. They took the 3.1 over to this side, getting that. Now they're going to divide both sides by 4.4, resulting in A is less than -3.5. On this side, We're gonna take the 9.1 over. We're gonna divide by negative 2.8, but when we do that, we have to flip symbol. Resulting in A is greater than 5.5. Yes,
So with the first half of the equation, did you not have to switch over the signs when you divided as well?
we did not divide by a negative.
Okay.
If you multiply or divide by a negative, you flip.
All right.
Positives don't change, just negatives. Okay, I guess that's why negative campaigns work so well. Supposedly they change things. Okay, we said this is an and statement. So we want the overlap, is what we're looking for. Well, let's graph it. Here's that one. Here's this one. There is no overlap.
So you just do the set.
So it's the intercept.
I was gonna say they, just a requirement to both of them to go the same direction.
Well, you going this way, you can tend to get overlaps. Once in a while, if they're both going the same direction, you can. But I can't force my elbows far enough apart to illustrate that. They don't work that way. I've had rotator cuff surgery on one shoulder and take shots for the other. A little side story, the rotator cuff surgery was thanks to an injury while I was on active duty in the Army and a 20-year-old. And I was going through a confidence course and I got hit by a swinging 300-pound log square on my shoulder and knocked me about 15 feet sideways. You know, with two chains, big log. It didn't really manifest it until I got old. But you find out things that work that way. Same thing with sunburns. You know, you get skin cancer through the nose. That's a different story.
So with the nifty set, there's no way of using like the notation.
Well, yeah, there is actually.
Yeah, how would you put that in notation?
I'm glad you asked. The set of X values such that you guys are going to start getting used to that part. X is not real.
There's a math statement, is there something not?
Or the set of X such that okay. I suppose you could write out the words, there is no solution. But one of those two will work. Fractions. Okay. These aren't any worse than the others. How do we get rid of that negative 2/3? We multiply by negative 3/2. It's reciprocal. Dolphin math, remember? Flipper. So I'm going to take this by negative 3/2 and this by negative 3/2. I'll put that over 1 just to make it easy. This one I take times negative 2/1. And that's just 1. So I don't need to mess with it yet. Okay, so there they're showing pretty much the same thing that I showed here. Oh, yeah, see, except they put this in front and I put it behind. Doesn't matter. And I didn't do it, bad on me. I didn't flip symbol because I'm multiplying by a negative. Okay. Well, the 3's cancel, the 2's cancel, the negatives cancel, you get 1x. Over here, 2 goes into 6 3 times. 3 times that remaining 3 is 9, and you got the negative sign. So here is your solution of this one. Now we'll do the same thing with that side. I showed 2 over 1 simply because it's in fraction form. You could have just shown 2. If it's 2 over 1/2, I typically show 2 over 1, so I have fraction. Well, obviously those 2's are going to cancel. I'm going to have to flip symbol because of that negative. Okay. And I also forgot to show that I multiply by -2 on this side. I was getting careless. Oops. So anyway, we got to this. The 2's cancel. The negatives cancel, leaving 1x. -2 times 1 is -2, so here is your solution to this part. This is an and, so we are looking for overlap, shared values. Okay, we're just bringing these over. I'm gonna get rid of this. Okay, there's the graph of this one. Anything, whoops, anything bigger than -9. Here's the graph of this one. Anything bigger than -2. Okay. So since it's asking for and, my overlap is from here to yonder. Okay. Say again.
Wherever the world's gonna be, that's where it's going.
Okay. Solution set. -2. X is greater than -2. Interval. Parentheses, -2 to infinity. You look a little puzzled. No, perfect. No, because this word and says it's only the parts they share. If this is said or, then you would be correct. It would be from -9 to infinity. Because basically this would include everything in that one also. So you really got to watch out for these words. Okay, here's another one. This time, fractions again. What are we going to do? We're going to multiply both sides of this by -4 over 1. And flip symbol. Over here, what are we going to do? First, we're going to take the 1 over there. Then we're going to multiply everything by 2 over 1. So that's our plan. Anyone want to see this one work before I go on? Yes, okay, will do. -1/4 z less than 5/8. Okay, so what am I going to do? I'm going to take this times -4 over 1. This times -4 over 1. And I'm going to flip symbol. Resulting in 1z greater than 20 over 8, but -20 over 8 a negative 20 over 8 reduces to negative 10 fourths to negative 5 halves. Okay? Did you follow me there? Even though I erased? If you can reduce, you must. What is the graph of this one going to look like? Here's negative 2.5. Or negative 2 and 1/2. And this arrow is going to go non-inclusive that way. Okay, what about the other side? 1/2 z plus 1 greater than or equal to 3. Well, once again, first of all, I got to get this add-on out of the way. -1 minus 1. So I end up with 1/2 z greater than or equal to 2. Okay. Now I multiply both sides by 2/1. And I can put that over 1 if I choose to. And these cancel out and I get z greater than or equal. I don't flip because I'm not multiplying by a negative. And over here I get 4. Well, what about the graph of this one? Here's 4. Anything bigger or equal? This way. Conveniently, the arrow tells me which direction to go. Always. If you have the variable on the left. If you have the variable on the right, then it's just the opposite. Okay, so what about the solution of this thing? It's looking for an intersection. So we're looking for shared in common. Well, here's a graph. Not a very straight line. Here I've got negative 5 halves this way, and I've got somewhere out here is 4, and it's going this way. So the shared areas for this problem are from here to there. Okay? Because both of these go forever. What is my interval notation? Inclusive 4 to infinity. Okay? Question about that one? Oh, guess I better erase. Yeah. I hope you're beginning to see that with just a very few little adjustments, that really fractions are faster. What if we had to divide everything by 2.5, long division? I mean, that'd be a pain since you can't use a calculator. And in fact, what we did, you could do faster than you could put the numbers in a calculator and then write them down. Okay, so now, what did I tell you that this was generally spoken of as? Inclusive, usually spoken as. Notice my language. That doesn't mean absolutely forever, okay? Because in mathematics, there can almost always be an exception. But inclusive here is what we're going to be dealing with right now. Okay, we give you this problem. Here is my guidance to you. Work each side by itself. Do not try to work both sides against the middle. Don't try to add -5 here and add -5 on there in the same problem. Break it down into two separate problems. This problem and that problem. You can see my Venn diagrams. Oh, by the way, you know those free cups they're giving away? If you take one of their free stickers and put it on it, it'll survive a dishwasher.
You're giving those out.
Yeah, there's a note out there that says if they're on the table, they're
Yo, I
free.
am blind, I did not see.
We
it.
also have stress balls, stress brains for you to squeeze, and cell phone holders. That's what those little curly things are.
Yeah, right.
But I'm French, I'm blind.
Okay, now that I've totally disrupted and distracted my
sorry.
class, let's go ahead and work this problem. Yes, question?
So to know it would be the and,
Louder,
to
please.
know it would be the and, I guess, is that when you go off to plus?
Well, because see the direction of these symbols? That's a clue for and. And you got something, some stuff in the middle, something with both symbols going that direction, less than or equal, or less than. That is a strong indicator for and. The two of those things together.
Is it, if the symbols are going the same way or?
If the symbols are going the other way, if I had had a greater than and a greater than, first place, it wouldn't be true the way this problem is written. But in the second place, then that would likely be an intersection. Notice my word, likely be an intersection. Okay? So anyway, let's work this one. We've taken this half of it and we solve it. I'm just gonna let them do it with some of my pre-made scribbles.
We got one more question here.
Sure.
How do you know to take the 3x plus 5 into both problems?
Because it's part of both problems.
It's not that.
You're making two steps. That is a valid statement by itself. That is.
Okay.
This is a valid, supposedly valid statement by itself. Okay? So that's the way you're breaking those out. Okay?
Okay.
Now, what we're trying to isolate X for the left half of this, for the right half of this, and then we're gonna look at where they overlap. Just like we've been doing.
Oh.
Is it the and thing? So
Yeah. So anyway, you can see all of the steps here already. Combine these, you get 9. Those go away, you get 3x. Divide both sides by 3. No negative signs, so we don't flip. And we get x, and -3 is less than x. But to graph that, we really need to switch it to this, to graph. Here's the other side. 3x plus 5 less than or equal to 10. Okay. Remove the 3 over, the 5 over, divided by +3, so we don't flip. And we get x is less than or equal to 5/3. And
So you don't take the second sign to graph it?
well, that one's already got the x on the left.
So the only reason why you're flipping it is to show which way the arrows will go. Your
With
X
the-
is on the left side of the inequality, it shows you which way your arrow is going, which way your line is going to go.
He's correct. On this side, the arrow is gonna go this direction. On this, where the X is in the left, the arrow is gonna go that direction,
Okay.
okay?
There it is.
Okay, we're bringing those two answers forward, including my adjustment. This would give you, based on this, maybe 3x is less than x, and x is less than 5/3, would give you this statement for your set notation. Okay? Now, here's what these do ultimately. They didn't show the subgraphs. I'll put them in there just for your information. I'll use red for this one. Here's -3, 1, 2, 3, right here. And non-inclusive and everything that way with the variable on the left. Okay, for this one, 5/3, which is 1 2/3. Right here, they've got it. It's going to be or equal and everything this direction. Now, based on these two graphs, you get this solution. What is the interval? Well, there's the set notation. We already talked about that. Yes.
So could you graph them separately?
I would, yes.
When you're doing that, when you take like the parentheses and the bracket, are you basically, so if essentially from that, if you're working backwards, they show you right there, you're gonna graph it on your own, would you just be using like the parentheses because it's on there already? And that's what first one is, yeah?
This word right here says only the inclusive part. Okay, only the inclusive shared part. So this graph stops right here. Although the 5/3 is actually included as a point on this line right here. You see, this one says we got points forever that way. This one, on the other hand, has an end point here, a non-inclusive end point, with points going that way forever. And what we've got to do then, because this says and, we've got to see where they overlap, what they share. And it's from here to here. And hence this. Now, did I answer your question?
A little bit, yeah.
Okay, what part didn't I
I'm
answer?
going to focus on the actual bracket itself, like the way.
Bracket
that it
means it's included. You could put your fingers in the fence. The point is there. Parentheses means it's an electric fence and you can come right up next to it, but you can't touch it.
goes.
So this means you could go to -2.9999999 infinitely, but you'd never reach 3.0. Okay,
So we've never reached -3 with the curve.
correct. You'd never reach it. I mean, you'd come right up to it infinitely close,
Never,
but you'd never actually touch it. Or included would be a better word. It is not included. Okay? It's a missing link. Is another way perhaps of thinking of it. Okay? let me draw maybe a slight illustration that might help. Coordinate graphing. Got a line coming up here like this. 1, 2, 3, 4, 5, 6, 7, 8, and so on. And numbers of this. That circle right there would indicate that you have two pieces of a line. You have this segment right here that ends here and ends there and does not include 4. And then you have this piece here, which does not include 4, but 4.0001, because we're on the bigger side, up to whatever this endpoint is. Well, this is the same concept of what we're talking about right here. That is a missing link, that exact value. Okay, hopefully I've done that without overkill, which is a danger for me. It's kind of important that we get you solid in these concepts, okay? So I'm gonna be pretty patient on questions about this stuff, okay? All right, this problem, this piece right here is out of sequence. All this is saying is, you see you got 2 is greater than or equal to that stuff, greater than or equal to that. It could be rewritten as -1 is less than or equal to that stuff is less than or equal to 2. In other words, you could completely flip this thing if you wanted to. Now, there may or may not be any advantage to doing that. Okay, usually not. So let's solve this thing. They are doing absolutely what I do not want you to do. They're working both sides against the middle. This is what, see, they took this -3, they tried to multiply this side, and they tried to multiply that side, but when they divided by a negative, they had to flip the symbols. That's what I don't want you doing. I want you to work as 2 separate problems, always. So,
Well, this is what you mean by that, like that, it gets really, really muddy really fast.
yes, it does. High opportunities for errors.
Yeah.
Very high opportunities. So, if I've got 2 greater than or equal to p minus 2 over -3. And I've got p minus 2 over -3 greater than or equal to -1. And I work those 2 separately. I am going to do this. I'm going to multiply both sides by -3. And accordingly, I am going to flip symbol. Okay? So this gives me -6 less than or equal to p minus 2. I've got to distribute that. -3p plus 6. Okay? Now, I'm going to take this -6 over. So -6 gives me -12 less than or equal to -3p. I'm going to divide both sides by -3. Flip symbol again. And that happens fairly often in problems, actually. And let's see, I'm going this way now. And 3 goes into that 4 times, and the negatives cancel out. And so I get this. So I'm going to circle that. Over here, I'm gonna do the same work. I'm gonna take -3 times everything and -3 times that. And I'm gonna flip symbol. So I get -3p. No, I don't. This -3 and that one cancels out. Okay? And you know what? I made a mistake over here. Someone said something that triggered a mistake on my part. These two threes cancel. Or -3s. So I should have had b-2 here. Okay? I'm glad I caught that mistake before you guys did. Okay, so anyway, and I did have to flip 7. I got that part right. I'm gonna take this over here, +2, +2. And so I get -4 less than or equal to p, or I can flip both sides like that. Now, over here, I get p-2 less than or equal to +3. Would I have to show that positive? No, because they're automatically good. I'm just doing it to prove the point that that's negative times negative is positive. I take this over. So +2, +2, p is less than or equal to 5. Okay. Here's 5. Looks like this. Notice the direction of the arrow. This one, using this form, here's -4. Like this, inclusive, and that way. Now, for the whole thing, -4, 5, 0. I've got this. I've got this. So my solution is whoops, brackets, -4, 2, 5. Both of them inclusive. Okay. That is the way I want you to show this work. I do not want you doing it this way. Okay, yes. Louder, please. Actually, I'm not adding the slash, I'm overriding it. Yes, I would do that. Do you have to do that? Am I going to count it wrong if you don't? As long as you got it correct on this step, I'm not going to count it wrong. But it shows me you're thinking about it up there and you don't get busy and forget it. And that's the point of me doing them up there. Someone over here started asking a question.
So is it like, would that be worth the partial credit points?
That one would, because it's all right. Now, what if I hadn't caught this mistake and I went all the way down and I went all the way down? I might still get a 3 because I only made one mistake, but I worked everything correct after that. If I were feeling generous. By the way, when I grade tests, I grade all students the same page before I go on to the next page. That way I have consistency in my grading point awards. Okay. That's just how I do things. It sounds like the sheriff 763. That's how they do things. They always did. Remember when it was talking about the robberies? 9 always took 9 cakes. Well, they're finishing this thing out. And you get that set notation, which we could have gotten. I didn't write the set notation. And ultimately the same graph. Here's what the set notation answer would look like. Okay. And there's the interval notation that we got. So much for this problem. Or statements. So far we've been on compound, we've been working on and statements. So now we're going to work on or statements. What does or mean? Either or. Anything that's in either one of them is going to be part of your solution. What's our process? Exactly the same. Do it in 2 parts. Okay? You can read this stuff. Whoops, went too fast. Solve and graph each one separately. Even the textbook is telling you that on this part. The reality is, if you try to do it compounded in an or statement, you will get a wrong answer. Now, if you get lucky on and statements, you can get the right answer working both ends against the middle. But don't. On or statements, you must work them separately.
Otherwise you are.
Otherwise, you're going to get untruths. Untrue statements. Okay, here we go. This one or that one? Well, we simplify the left. We're going to have to divide by a -3, which means we flip symbol, and we get that statement. We simplify the right. We take this over here, get 2. We're going to have to divide by a -1. And we flip symbol. And we get that statement. Now we graph them just like we did before. Okay, there's continuation from the last. Here's this one. Y is anything littler than -3. And this one, Y is anything bigger than -2. Now, what is the solution? Well, there's the solution, because it's anything in either or. Okay? We got a gap. That means our interval notation is going to be split with a U in the middle. Okay? Now, here's the set notation. You actually have to physically write in the or to get it.
There's no fancy symbol for it.
Well, yeah, I mean, you got the, you could put union, you could put a union symbol there, but usually we just write the word or. Okay, now, here's the interval notation. This stuff, right here. This stuff, right here, with the minus in the middle. Or the gap in the middle. Yes,
Why is there a bar behind the second one in the solution?
here?
No, down.
Yeah, where?
The solution
The solution
is-
is,
Y, and then there's a
Oh,
2 at, therefore.
this is saying the absolute value of y. Okay, the absolute value of y is less than or equal to -3. Would I count it wrongly on that problem if you didn't put absolute value? No. Should you? Yeah, probably. Okay. So anyway, solve this one. We do the left side. We do the right side. We do have a flip on the right when we divide by that -2. Okay, this is an OR statement. So here's the graph of 13/4 less than, or 13/4 is greater than X. So it's all the numbers that direction. And I intentionally said that backwards. Okay, and here is the statement for -3/2 is less than X. So that means that everything goes this. Now, the reason I said those two backwards is I said them as if you had had the variable on the right. And it would have been hard to figure out the graph. But the graph, put the variable always on the left, they're easy to graph because the arrow tells you which direction to go, or the symbol does. All right, so what is the answer? Since this is OR, it's anything in this one. So from here that way, and from here this way, it's got some overlap, but you know what? We don't care because it just says anything that's in either one of them. Remember that very first set where we had pairs of A's, pairs of C's, and pairs of E? This is kind of like that. You know, we've got pairs of values from here and from here, but we only list it once. Same kind of an idea. Okay, so that's our total graph. Infinite negative to positive infinite. Infinity and beyond. Remember me telling you this answer earlier? X is any real number except I use that double-barreled R symbol, except Alex won't recognize that symbol, so you'll have to write it out like this. If they ask for %. Interval, much simpler. Applications. Translated word problems. I'll let you read that. Whoops, too fast. Sorry. There you go. From 0.04 to 4.8. And everything inclusive. That's what this statement is saying. Now, do you understand what math speak is in English? Okay. From here to there, from here, everything in between to there is what this statement is saying. And how do we know it's between? Look at the direction of those symbols. Okay. So we did that. We wrote this inequality. Now we got to solve it. We're going to take the left side, and then we're going to take the right side. Oh, that's a totally different problem. They never finished this. All they ask you to do is write the inequality. They didn't ask you to give the interval is going to be brackets 0.4, comma, brackets 0.8, 4.8 is going to be the interval.
So how do it with less than?
Because that right here, when it says from here to there, that means this is the smallest one, the littlest one. And we get bigger until we get to the 4.8. 4.8 is the biggest. 0.4 is the littlest. So this symbol indicates that anything in here in the between area is bigger than that one, but still yet smaller than that one.
So that's technically all.
Anything in between there. And because of the OR equals, the actual points themselves are also included. Okay. This is just, instead of any expression writing exercise, this is just simply a inequality writing exercise. That's all this is. They want you to write the formula for this thing. The sum of twice the number and 11, right there, is between 21 and 31. 21 is the littlest number, 31 is the greatest number. Now, does that statement make sense to you? Okay. You guys never bring me in English class.
But sometimes, I mean, honestly, you are professional, more professional in English than some of my.
So I don't know whether to take that as an insult or a compliment.
No, that's a good thing,
No,
trust me.
I'm teasing.
Oh, yeah.
I'm teasing. Let me see where we are. Okay. I need to keep on going to absolute just for the few minutes we got to think. Okay. A is a real number. That one. Okay. That means that whatever this is had to be either positive or negative A to get that answer. Now, if A is bigger than 0, then this. You have those two possibilities. Okay? If A is less than 0, meaning a negative number, you see that symbol, that means we're talking about negative numbers. There is no solution to the equation. Okay, why? Because you can't take the absolute sum and get a negative value, a negative outcome. But there is this truth. So we have a way of dealing with that. When we remove absolute value symbols, the solution to that, because negative A, absolute value, could give you positive A, and positive A, absolute value, could also give you positive A, we have to list both possibilities in our answer. Example. Let's see. Okay, here's an equation. Okay. Now, notice I'm using an equal rather than an inequality right now, because that makes a difference. If I remove this parentheses so I can mess with this, because I can't do anything with it right now. So if I simply remove those parentheses, those
Brackets.
absolute value symbols, and which, by the way, they also behave like parentheses. Then I have to have this. Okay? Meaning, this originally could have been positive 3, this originally could have been negative 3, but we don't know. So this generates, in turn, two problems. X plus 2 equals positive 3, and x plus 2 equals negative 3. Okay? Take the 2 over, minus 2 minus 2, x equals 1. Take it over, plus minus 2 minus 2, x equals negative 5. Okay, now, we can graph those just like we've been doing. Okay, except they're just gonna be 2 points because there's no inequalities. But what if this had been, anyway, there are 2 possible answers because of this absolute value. Later on, you're gonna find that the graph of an absolute value is always a V. One for the positive leg and one for the negative leg. For you, it would be positive and negative. Okay? So what if we had instead in this problem a less than or equal there? Well, right here, we would still have that. But down here, although we would still have less than or equal here, on the negative side, we would have to flip. On the negative side, you always have to flip. Simple. Okay? So in this case, your answer is going to be x is less than or equal to 1. And in this case, your answer is x is going to be greater than or equal to -5. And then we could in turn graph those. Okay, here's 1. Here is -5. Okay, this one, we got less than or equal to 1, so it would be like this. That one, we would have this. So what would our answer be? No, it's a positive one. That would be the answer. Okay? Now, that's the fundamental idea. Yes,
Could you explain again how you change or why you change the signs on the right side?
I changed the signs on the negative side. Okay? You will always have to change the signs on the negative side. Now, later on, we're going to work some square root problems. Okay? When you take the square root of both sides, you generate a positive negative, just like we did here. Okay? And if it's an inequality on the negative side there, you will also have to flip symbol. Okay? And with that, it's time to go. A little bit past, maybe a couple of minutes. Have a good evening.